Hello everyone. Today's topic is Scott connection. The Scott connection was proposed by C.F. Scott. By the theory of C.F. Scott, we will be able to obtain three-phase to two-phase supply, or using the Scott connection, we will be able to convert two single-phase transformers can be used to supply the three-phase and vice versa. That is, three-phase to two-phase conversion and vice versa can be done using Scott connection. Generally, it will be used in the furnaces, or even three-phase loads can be driven from the available two-phase supply source. Now let us understand by seeing the circuit. So Scott connection is the mixture of two single-phase transformer. One transformer we call it as main transformer. So which transformer we call it as main transformer? The main transformer, here you can see this is the main transformer. The main transformer is having center tapped. Here you can see the center tap represented as O, and as shown in the figure, it has n number of turns, or we can consider as n1 number of turns, and it is connected between the terminals. Now when you see, there are two types of transformers as we can observe here in the diagram. One is called as main transformer, the other one is called as teaser transformer. So teaser transformer, what it has, you can observe here, the teaser transformer has 8.866 N1 turns. So one end of this is connected to here, one end of this is connected to center tapped point of the main transformer, and the other end is connected to here. The other end is connected to R, supply R. Now as we can observe the diagram, we can see here the voltage across the secondaries are equal here. Both the voltages will be equal voltages in magnitude and having the phase difference of 90 degrees. Now Scott connection of two single phase transformers, generally as we can see in the circuit, will enable us to convert it into three phase supply to single phase supply. Now I will write a small phasor diagram here. Let us consider this as point B, C, Y, and this as our R. So here the voltage, let us consider as V, CB, that is voltage between CB, and voltage between Y and C, and this is the voltage between B and R. So this is our 30 degrees. So this is called as root 3 by 2 times line voltage Vn. Now the center tapped primary of the main transformer has line voltage. Which line voltage? It has the line voltage of VYP when you observe from the diagram. So which is applied to its terminals. The secondary terminal voltage of the main transformer is nothing but it is V2. So V2, from the diagram we can say V2 is equal to N2 by N1 into VYP. Right? So because we can rewrite this as N2 by N1 into V2. From the phasor diagram, what we can observe is the line voltages of the three-phase system, that is VRY, VYB and VBR, are balanced, and they are shown on the phasor diagram as a closed here equilateral triangle. As you can see, closed equilateral triangle. Now the voltage across the two halves of the center tapped primary of the main transformer VCB, here you can observe VCB and VYC are equal, and they are in phase with VYB. So VYB is the total voltage. So when we observe the diagram here, the VRC leads VYB by 90 degrees. 90 degrees. So VRC is applied to the primary of the teaser transformer, and hence the secondary voltage V1 of the teaser transformer will lead the secondary voltage V2 by 90 degrees, as shown in figure. Now the magnitudes of V2 and V1 are equal. Now when we consider here VRY is equal to VYB is equal to VBR all are equal to line voltage VL. Now from this we can write from the phasor diagram VRC is equal to VRY cos of 30 degrees. Now this can be rewritten as root 3 by 2 cos 30 into VL. Root 3 by 2 is 0.866 VL. Now what is V1? V1 is equal to N2 by 0.86 because you have considered only 0.86 N1 turns into VRC. So this is nothing but N2 by 0.86 N1 into, we can replace this VRC by 0.866 V2. So what it gives? It gives N2 by N1 into VL, or that is equivalent to V2. So what we say, if the load is balanced on one side, it would always be balanced on the other side. So this would prove that by taking only two transformers, two winding transformer, we were able to operate it as a three-phase transformer. So this is all about this Scott connection. Thank you.